Yeah. Okay, just want to get a minds on with you. Some of you may have already gotten the handouts printed. If not, use this time to do so. I'm going to get working on this minds on with you, and then we'll go straight into the examples. Today's lesson is going to be another kind of skill that you need to have as we navigate through grade 11 math, and that is dealing with radicals, aka this stuff. It could be a square root, it could be a cube root, it could be a fourth root, a fifth root, so on and so forth. But when you have this root sign, um, it actually represents something we're going to look at a little later in the year. For the moment, you need to know how to work with it, what it means, and so on and so forth. So, take a look. I'll just go through this minds on and we'll do the lesson first before I ask people for their input. Just listen carefully. Opposite in terms of operations. The opposite of addition would be, whoops, subtraction. Right? Let me see if I could erase this without, whatever. It's my fault. Opposite of addition would be a subtraction. The reverse of multiplication would be division. But when you have something to the power of 2, it could be this, it could be this, it could be this, whatever. The reverse operation, to get rid of a square root, you would have, sorry, to get rid of a square, you would have to do a square root, right? It would be the square root of 2. And by default, if there's no number, no tiny extra superscript number on the root, by default, we assume it is a square root. Okay? So root of 3, root of 2, root of x, so on and so forth. So this is what we're going to get used to using, and I'll tell you the reason why. But first, let's get into the correct mindset. So I don't need this right now. Actually, if you want it back, if you want to copy it down or something, you can. 3 plus 3 is like I saying I have 2 of 3's, right? 2 times 3. I have 4 plus 4 is like saying I have 4 2 times. X plus x is like saying I have x 2 times. So when I say root 7 plus root 7, does that change anything? What can I rewrite this entire addition as?
Is it root of 49?
Follow the pattern.
No, I'm not. Leave it off.
Think about it. Think about it. If I have three, something plus something,
Oh,
it's
oh,
essentially the same as me saying I have twice the thing that I'm looking for, right? I have the twice of whatever it is I'm talking about. So if I have 3 plus 3, I have 2 times that value. If I have 4 plus 4, I have 2 times that value. If I have x plus x, I have 2 times that x. That's why we write it 2x, right? But if I have root 7 plus root 7, does anything change? No. I have 2 of root 7. Okay? So if I were to say I have root 2 plus root 2 plus root 2 plus root 2, how many of those do I have? 4. So you can rewrite it as 4 times root 2. Just like if I were to say I have x plus x plus x plus x, sorry. If I have x plus x plus x plus x, I can rewrite this as 4x. Same stuff. I'm going to do this again, so just listen for today, and then we'll do the exercises together. Next, when we're multiplying, it follows the same rules as regular numbers. If I say 3 times itself, well, I can rewrite it as 3 squared, or I can solve it and say it's a 9. If I say it's 4 times 4, it's 4 squared, or 16. If I say x times x, well, that's x squared. And of course, I can't solve that because I don't know what x is. So I'll just leave it. But what if I have root 7 times root 7? That is the same as what squared?
Root 7.
Yeah. And I just said that the root is the opposite of a square. They can sort of cancel each other out, giving me a 7. Any questions for so far with what I just said? Going once, going twice.
I have a question.
Yep.
So if you multiply two roots of the same number, it'll just take the root sign away, basically.
Basically, but that's where I want to start my lesson. 7, right? You can say that 7 is actually the same as square root of 49. It's like, what times what gives me 49? 7, right? So take a look at how this and what I know about the number 7 match each other. Wouldn't you say it's virtually the same thing? Right? When you are multiplying radicals, by definition, because of what I wrote here, you can argue that when I'm multiplying radicals, just multiply the numbers inside the root sign. And that's going to be a skill that we practice. If you get this, we've already done half of our lesson. Okay, so bear with me here. I'm going to switch over and share to my camera. So let me share. Does someone need some extra time? Are they trying to copy this? Do they need some time?
Yeah, just 1 second.
Okay, sure. Everyone else, get your chapter 1.4 sheet ready. I'm going to start with a little bit of math terminology because you're going to need to know how to communicate it using proper math terms, math words, and then we're going to practice it together.
Okay, I'm good. Thank you.
All right, let's do this. Stop share, and I want to change my camera to my desk document camera. And I need to shoot. Let me pause this. Okay, better. I fixed it so that you can see my paper. What you might want to do is change the view into speaker view and pin me. So you can just see my document in close-up. Okay, let me try to focus here a little bit so you can see better. All right. Hope everyone can see me. I'm going to get started with the lesson. Where's my pen? Here it is. Okay. If this goes well, we'll be done really early. If not, then I don't mind. We can keep on practicing. All right, so let's start with some terminologies. First term is the word radical. Anytime you see a root, it doesn't have to be a square root like this. It could be a cube root. It could be a fourth root. It could be so on and so forth. You get what the point. But if you see the sign of a root, we're going to call that entire thing a radical. All right? Term number 2, the most common thing we're going to talk about is the number inside or underneath the root sign. The number within the root sign is, we're going to refer to those numbers quite often. We give it another name. The number inside the root is called the radicand. You know, let's just get used to using these new words. You'll be okay. All right? Another thing that we're going to work with a little bit is something called a mixed radical. If you recall, if we have something like this as a fraction, we call that a mixed fraction. Why? Because we have the fraction portion and we have a whole number portion, right? So a whole number fraction together is a mixed fraction. That's what it is. Another thing we might refer to, there's a number in front, that would be our whole number, and it is being multiplied to the root. Okay, we can just for the sake of ease, we can refer to this as a coefficient as well. Some people don't share that opinion with me, but we'll move on. And the last idea, you don't have to worry too much right now. I'm going to put a little star next to it. Typically, when we work with roots, when we simplify it, we simply assume that the answer is going to be positive for now. I know in grade 10, I know in the future, if you have, let's say, square root of 4, the answer could be plus 2 or minus 2. The way we write that is plus or minus 2 like this. But for now, as you can see, when you'll see in my examples as I work through them, I'm going to assume that it's a plus for now because we're trying to focus on the technique and the skill. We're not trying to use this for or applying it to things like quadratics and trying to solve a mystery question here. Okay? So for now, when we do simplify it, don't worry, it's going to be just a positive. Okay? And also as a summary, what I just talked about in the minds on is sort of what is it? Is sort of summarized here. And this we'll get to in just a second. So let's work on these two and how we can apply that in regular questions. And then you'll see an example of a division sometime soon. And that's when I'll get to that and explain it. Any questions before we start? We're good? Great. Let's get to it. When we are multiplying radicals, all we have to do is multiply the radicands together. You don't have to worry too much about anything else. So, why is it not focusing the way I want to? Okay. How about I go in reverse order? Will, with what I just said, would you mind giving this one a shot?
Sure.
So, you've got a radical multiplied by a radical, and by definition,
So it's 16.
it's 16. Right on. Right? When we have two radicals, the roots are the same degree. When they're multiplying, all you have to do is worry about
The radicand.
radicand. Thank you for using the terms. How do you pin a screen? You can click on the three dots on my chat. There should be an option that says pin. Alex, did you find it? And then once you pin, turn the view into speaker view. Here, let me do this. Do you see my chat boxes? Sorry, do you see my I don't even know if you see what I'm seeing. There should be a thing right here. No? You see it? If you look at the screen where I'm showing the document, in other words, my little camera window, on the top right corner, there should be a little button that has three dots on it. I wish I could show you what I'm seeing right now. Let's see. Screen share sound optimized for video. Yeah, so Daniel might have the right idea. Try going to the gallery view first, and you will see a whole bunch of people already, like, that's part of this class. Okay, perfect. Thanks, Daniel. So now we have 16, and what do you remember about the number 16? It's a perfect square, and that can actually be 4 times 4. Yeah. So root 2 times root 8 is actually just 4. Okay, let's try the next one. This time, or how about we skip the b because that's addition. Let's do some more multiplication. This time I have some coefficients. But as if I am doing 3x times 4y, you don't have to worry about the radicals, just follow the same rules. When it comes to the coefficients, you group them together as well. Okay, so after Will comes Sydney Kendall. What do you think?
Would it be 12 and then 15? Well, square root and then 15.
Perfect. That's all it is. That's all it is. Good job. Can I reduce this any further? Can I turn this into a smaller whatever? We'll get to some of those examples later. Don't have to worry. Now that we've tried multiplying, how about we try dividing?
Can you
Divide
go
by
back up
2.
for a second?
Pardon me?
Sorry, can you just go back up for a second? I just wanted to see.
Like that?
Yeah, I was just looking at the C.
Oh, C. Yeah, there it is.
Okay, that's good. Thank you.
Okay. All right. Divide by 3. Don't think of this as a fraction. There's no real division involved. This is actually the same as 12 times that. It's like it's a number. You don't divide for no reason. Okay? Let's move on to D. D is a division, and just like how we were multiplying the coefficients and multiplying the radicals separately, when you have a division, you follow suit. So you can divide the coefficients and divide the radicals on its own. Okay? So after Sydney F, 6 divided by 2. Oh, awesome. The chat, 3 to 1, good. And then 15 divided by 3. Good. That's a 5 and that's a 1. So this becomes 3 root 5 over 1, which I'm not going to write. That's it. That's multiplying and dividing radicals. Okay? Any questions? Otherwise, Monica, I'm coming to you.
For B?
Yeah. No other questions? Because Monica is excited to try B.
Yeah, I'm so excited.
So excited. Okay. For adding, let's go back. When we are adding the same radicals only. Okay? Just like how if we have x plus x, that can become 2x. But if we have x plus y, two different variables, you cannot go further. Okay? So in the same way, if you are asked to add or subtract radicals, look for the common radical first. What do you think?
So it's root 2, so then the answer would be 2 root 2 plus 2 root 3.
Perfect. So these two are common radicals, and the root 3 is on its own. So 3 subtract by 1, 2 root 2 plus 2 root 3. Done. You can't go any further.
If we see these in like a quiz, should we solve for it, or should we like just leave it at that?
I would actually expect you to leave it at this because this is considered exact values. I was going to get to this later, but since you brought it up, and thank you for that, I am going to show you why radicals are actually going to be super important in the future. If you have a calculator, or you can just follow me, I'll bust out my calculator. Okay. Take a look. Root 2 on its own, my calculator gives me more than 8 digits. Oh my gosh, close. I do not care about cryptocurrency. Stop it. Okay. If it is, my calculator gives me more than 8 digits, but it actually shows no sign of repetition. In other words, root 2 equals 1.414213, so on and so forth. It is what we call an irrational number. There's no sign of repeating, there's no sign of ending. So we actually don't know what the final value of this is. As a mathematician, would you rather use decimals or would you give me an exact value? For science, because we're applying math, we probably want to round that. But in mathematics, we actually prefer the exact value. So if you gave me the decimal, you're technically less correct.
What if there was a situation where you did get an exact value, like if it came out to like 2 or to 5 or something?
Well, if you, for example, if you got like 2 root 4, I would absolutely expect you to simplify that.
Okay, that makes sense. Thank you.
Okay? Irrational, leave it. And that's going to be something that you'll see in the future. All right? All right, let's move on. Thanks for asking. Here we go. Express as a mixed radical. So here's another skill you're going to need. There are times where the radicand is way too big, and there is a way to express the radical in a more simpler way. What I'm going to ask you to do is turn this into a smaller number and see if you can identify whole numbers out of it. That's a mouthful, so let me just demonstrate it. I would like you to break down the radicand into a multiple of 2 numbers, and I would like one of them to be a perfect square. If you're not sure what a perfect square, it is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, so on and so forth. I would like 48 to be a product of 2 numbers, and one of them, preferably, should be a perfect square. Alex is really quick to that typing. 12 and 4. There's actually a bigger number you can do, but for the sake of demonstrating, thank you for using the smaller of the two. 4 and 2. Take a look at what's happening. Root 4 times 12, okay? Root 4 times 12, root 4 times 12, root 4 times 12. Do you remember when we had a root times a root? That is the same as root of 2 times 8? Preferably. You'll see, Alex. You'll see what I'm doing, right? If I'm multiplying 2 radicals, it's basically one root with the radicands multiplying within. Who's to say that if I can turn this into this, that I can't go in reverse? So when I have a radical with a multiplication, I'm going to break it apart into 2. Did you guys just hear that? Did you guys hear like a dying giraffe in the background by chance?
Heard a baby.
Yes.
Yeah. Okay. That was my 4-month-old. But she's not dying. She's not dying. That's not what I meant. She's not dying. Okay. Stop it. Okay. So the answer technically would be a mixed radical 2 root 12. But I think we can go a step further. 12 is a product of
4 and 3.
4 and 3. Thank you. So that's 2 times a root of 4 times a root of 3. A root of 4 is 2. So it's 2 times 2. The final answer is 4 root 3. Root of 48 can be written as 4 root 3.
Wait, do you just like get rid of the 2?
Hmm?
Like on the second last line, it's 2 times square root of 4 times square root of 3
Uh-huh.
into the first 2.
Oh,
Oh, I get it. Okay.
got it?
That makes
Got
sense.
it? Yeah, okay, I got it. I like that. Okay. So let's continue. So anytime you're trying to reduce it in simplest form, so that we can do this, we're trying to break this down into a multiple of 2 numbers in hopes that one of those numbers is a perfect square. Because if it's a perfect square, I can turn it into a whole number. That's the goal. So let's do it. After Sydney F comes Monica, and after Monica comes Marin. Marin, can you give me 2 numbers that multiply to 54? And preferably using one of these. Okay, Marin's AFK for a sec. Maddie?
9 and 6.
9 and 6. Right. And it's nice that you use 9 because I know that is a perfect square. So I'm going to rewrite this as times 9 times 6. So, done. And 6 cannot be broken down into any perfect squares, so we just leave it. Oh, sorry, Marin. Oh, that's my bad. That's my bad. I didn't mean to.
Can I ask a question about A?
Yeah, sure.
So from the point where you have 2 and then you have under like the square root, you have 4 times 3.
Uh-huh.
And then you go, how did at the bottom, how did you get 4 over like the square root over 3?
So, do you know how I got to here?
No, like I'm getting a little confused how you got to like the next few steps.
Okay. So, in the previous example, if you take a look at root 2, root 8, right?
Mm-hmm.
When I have 2 radicals multiplying with each other, I can rewrite that as root of 2 times 8.
Yeah.
Which is the same as root of 16. This time I'm doing it in reverse. If I have a root with a multiplication, can I not separate them as a multiplication? So if I have a square root of 4 times 3, it's the same as square root of 4 times the square root of 3.
Sorry, I'm like, how did you get 4? How did you get to the next step? That's the part I'm kind of confused about.
So from 12 to 4. Is that what you're saying? Is that what you're asking?
Yeah, from the
So when I saw the 12,
sorry, I mean from sorry, this is so confusing. From
okay.
2 times 4 times 3, how did you get that to the 4 3 squared? That one.
Oh,
How
4
did you
squared.
get those
Okay.
2?
I am simplifying. So from here to here, that is the same as, that's 2. And the square root of 4, I actually just solved it. Square root of 4 is a 2.
Oh, okay.
Yeah. So I just did the square root
Okay,
of 4
sorry,
in my.
thank you.
Yep. All right. So in the same way, 5 root 28. I would like to break that down into a product of 2 numbers. And one of them, preferably, is a square root. So we've got, who's after Maddie? Lynn?
Yes.
2 numbers, please.
4 times 9.
4.
Sorry. 4 times 7.
Good, thank you. So that is 5,
Uh,
4,
7.
7. So I'm going to rewrite it as, there you go. Any questions?
I have a question.
Yes.
Based on the ones that we just did,
Mm-hmm.
how much harder are there going to be examples where like you have to filter?
How about we go through the next page and you'll see.
Got it.
Okay, so there's from here, there's 2 levels above I would like to throw at you. They all involve small tricks, but you'll be fine, in my opinion. All right, so this is the back page. Once we complete this, I want to give you a 5-minute break before we reset. Root 12 plus root 27. Can you add that based on our original rules? Kennedy.
No.
Yeah. Well, you can like.
Don't worry about it. Let's take it easy, okay? When you're adding, just like what is it? Just like variables,
Oh yeah, they
right?
have to be like terms, right?
They have to be the same radicand. So in this case, you'd be like, "Oh, Mr. Kim, you made a mistake. I can't go any further." It's true, but there's one thing I'd like you to try first. Try turning it into lowest terms, and you might notice a commonality. So, Kennedy, stay with us. What can I rewrite 12 as?
So 3 and 4, and then you
Yeah.
can simplify the 4 to 2.
Good. So let me do that first then, because you've already jumped that. And what about 27?
3 and 8? No.
Close,
Why am I forgetting my timetable?
because I'm pressuring you. So
3
that
and
would
9.
be,
Sorry, 3 and
yeah,
9.
root of 9 times root of 3. That's the same as, there. When you do it in simplest terms, you actually find that they can be written with the same radical. And that happens. Kennedy, can you finish that off?
So now you can add the.
Yes.
Would it be 5 and then 3?
Yes. Done. Okay, so let me try to write this out. That's the root 4 is now a 2. The root 9 is now a 3. And you just add that together. After Kennedy. Josh Hardy, I'm coming to you. While people might be copying, could you take a look at B? It's the same situation where you can't add it right away, but before you come to that conclusion, maybe you want to try reducing some of them. What do you think?
Could you turn 10 into root 2 times root 5, even though it's not a perfect square?
You can, but it doesn't actually help us. Right? Because if you turn this into root 5 plus root 2 times root 5, you're essentially adding 1 and root 2. It gets a little messy. You don't want to do that. In other words, you're right in being a little bit confused. You can't do anything to root 10. It's better to leave it as root 10.
So could you do 20 to root 5 and root 4, which is 2?
Perfect. Exactly. 4 times 5, so that is root 5, 10, and 2 root 5. And then once you do that, you realize the bases are the same. And so, or bases, the radical part is the same. And so,
3 root 5 plus root 10?
yes. Pausing right here. Any questions?
Could you repeat why you said not to do to simplify root 10?
Oh, root 10 cannot be broken down into any perfect squares.
Oh, okay. Yeah, sorry.
So, I mean, you can try, right? Like this could be root 5 plus root 2 times root 5. Then what are you adding? You're adding 1 plus root 2, and all that's multiplying to a root 5. It doesn't make it any prettier. It stays sort of messy. So it's probably not something that you want. Any other questions? Okay. We'll try C, and I'm going to give you a 5-minute break. When you have a number in front of a bracket, just as always, you would perform distributive property. That doesn't change with radicals. So after Josh K, what do you think?
Yep. You want me to answer?
Yes, please.
Do we have to distribute it?
Yes, we do.
Okay, so if you're multiplying radical, the 2 and the 3, it would be 2 times 3, or the square root
Good.
of 2, 6, and plus 2 times 18, so 36.
Nice. That was quick. And then that we can't do anything about. We can't turn that into mixed radicals. But this one,
Plus the root of 6, or it's square root of 6.
Yeah, that's it. Okay. D, I'll just leave that as is. In just a second, I will upload a answer key for these, so you can try it at a later time. At this point, radicals can be a bit of a, some people might find this a little much to chew on all at once. So give it a shot. Why not try D, or try looking at the previous questions, redo them on a separate piece of paper if it makes any sense to you. I'm going to ask everyone to reconvene at exactly 2:50, and we're going to do part 2 of this lesson.
I have a question.
Yep.
At the bottom of the page, it says homework. Read examples on page.
Yeah, that's my fault. That's a sheet that I would have had if you got your textbook already. So don't worry about this. But you can take a look at the Waterloo question examples if you like for more practice. Okay?
Thank you.
Yeah. Sorry, that's my fault. I should have edited that out for COVID. Square root of 9 plus root 3 minus 2 root 3 minus 2. That's a 3. Negative root 3 minus 2. There it is. Ah, boy. Okay.
Mr. Kim,
Yes.
was the answer to D 7 minus root 3?
Not 7.
Oh, I didn't square root it. Okay, that's my bad.
Oh, I see what's happened. Yeah.
Mr. Kim, why does the 3 go to a 1? Oh, never mind. I understand.
Yes, I am. Anytime you have multiplication, it's distributive property. Distributive property is the proper name for FOIL, is generally what I'm using. You know what they call this in Jamaica? They call that bird beak. I was teaching I was at an inner city school, and there was one student from it was when I was way young as a teacher, and he had no idea what I meant by distributive property. He had no idea what I meant by FOIL. But when I showed him and I drew these arrows, and he's like, "Oh, bird beak." It was a good day. It was a good day. So good. For those of you who are sleeping, may the sound of my laughing baby wake you up. Yeah? 1, 2, 3. Standing! Okay, again. 1, 2, 3. Standing! Isn't she wild? She's crazy. She's not even 4 months and she's like acting like she knows this world. Okay, anyway. Yeah, my baby is very chubby. You know, if I could draw on this piece of paper, like if this was her legs, she had 4 underwear lines because that's how many rolls she had. She has like 3 rolls now, but it's pretty bad how chubby her legs are. Anyways. Anytime I can, I show off my babies. Anyways, shall we start? I'm hoping everyone is back. I want to get started on part 2, and the faster we finish this, the faster you can take your break. Alright, let's do this. Part 2. Sometimes when you are working with rational... You know what? Is everyone here? Am I just talking to... Am I talking to a wall? Is everyone here?
We're here.
You got 4, you got 5. Okay, people, you know what? That's enough. I'm gonna start it out. All right, people. Part 2. Sometimes when you're working with rational expressions, with radicals, sometimes you can find the radical in the denominator, and that is a big no-no. You cannot give me a final answer with the radical in the denominator. And this is my argument. Using my calculator once again, you know this. You know what this is supposed to equal to. If I do a square root of 2, it ends up being something like this. So if I were to actually write this out, square root of 76 is divided by 1.41421 blah 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 blah. That, as I said before, is irrational. We can't have that. How else it... You know what? Let me describe it this way. I am dividing by a number. I have a number, but I actually don't have the number. I can't divide by a irrational because I do have a value, but I don't have the exact value. So I don't know what I'm dividing by. Does that make sense to people? Does that sort of make sense? I have the number, but I actually don't quite have the number to divide with. Right? So having a radical in the denominator is a big no-no. How do we get around that? Well, if you want to do what we call rationalize the denominator, we are going to use that same trick of multiplying by a 1. Rather than explaining it, it's better for me to show it. You ready? 3 over root 6. To get a radical out of the way, I am going to multiply by a 1. Right? Does that make sense? Because any root, anything, like it could be a 5, multiplied by itself is square root of 25, which in turn just gets rid of the square root. It becomes a 5. Why does that make sense? Well, I can say that this is root of 25, but this number is multiplying it by itself, so I could also say it is the root of 5 squared. And we mentioned before that the square root and the square are opposite operations. So that is why whatever the denominator is, we're going to multiply it by the same thing in the form of 1. Okay? I think after Josh, I think Jordan, you're next. Could you perform this for us? If you're with me? No? That's okay. James?
Yes.
Okay. The numerator is the same. What happens to the denominator?
In this situation, multiplying by it becomes 2 times. 2 times. I forget. I'm just forgetting the word. I'm kind of blanking. But 2 to the or 2 times the square root of 6. Sorry.
Oh, I see. Well, remember, they are multiplying. If I were to add, that would be true.
Oh, sorry.
Right?
36, right?
Root 36, root of 36, which is the same as just 6. Right?
Okay, yeah.
Yeah. So we have that, and let's simplify further. 3 and 6 can reduce.
Yeah, you can go ahead. Yeah, that's
Become
Mhm.
2. Good. So the answer is root 6 over 2.
Okay.
I know, it seems weird, but 3 root 6 and root 6 divided by 2 are going to give you the same thing. You ready for this? 3 divided by root 6 is... Oh, you can't... Okay, one second. There it is. 3 divided by root 6 is 1.224. Root 6 divided by 2, 1.224. And they should be the same because I'm multiplying by a 1. It shouldn't change the value of this number and that number. Okay. Let's try it again. Ivan, I think I'm coming to you. I have a radical on the bottom, on the denominator. How do I get rid of it? You can pass. Not a problem. Alright, maybe Ivan... Oh. Yeah, multiply square root of 2. But I can't multiply it out of nowhere, so I'm going to multiply it by 1. That's a 1, right? Maybe I should square it with the highlighter so that people know what I mean by 1. And so multiplying across. Sorry, Ivan, I didn't mean to I didn't realize you had to type it all. I'm not gonna, you know, make it hard on you by typing the answer. Hazel, could you multiply across for me?
Does that become 3 square root? Or wait, do I have to do distributive property?
Yes, exactly. This applies to both. It applies to everything.
Right. So that be the 2 is
Yeah.
distributive.
So I wrote the square root already, and I don't have a whiteout. So it's 3 square root 4 minus.
10. Negative 5. Oh god.
Don't worry. Don't worry. Great. What about the denominator?
That's just as
Good. Wait, did I hear that right? 'Cause you're so faint.
sorry, pardon me.
Go ahead.
That becomes 1 or 2.
2. Good. And let's simplify. As you said, square root of 4 is actually a 2, so it's 3 times a 2. There it is. That's it. Let's try some more practice. Felix, you with us?
My space bar isn't working. There we go. Okay.
All right. What do you think? How do I rationalize this?
Um. Oh, turn it into 5, and then you can multiply the 2 by 5 as well, so that's equal, right?
Yep. Here we go. You're multiplying it by root 5 over root 5. So the numerator is 2 root 5, and the denominator is square root of 25, which I can simplify into just 5. Same thing, following suit. Aaron, how do I rationalize the root 3? Aaron, you with us? No? That's okay. It's okay to pass, but I would like everyone to be here. Daniel Rain.
You multiply by root 3 over root 3.
Mm-hmm. Can you finish?
And then that becomes negative 4 root 3 over 3.
Good. And you're done. Excellent. Dahlia?
Multiply by root 3 over root 3.
Yep. You don't have to worry about the negative.
And then that becomes 6 root 30 over negative 3.
Good. And then, oh, those numbers happen to.
And then reduce to negative 2.
Good. Because that's divided by 3, divided by 3, 2 over negative 1. So here's an interesting example. From here, I'm going to go straight down to here. Before you actually multiply the 1, make your life easier by simplifying. You have the 18, you have the 3. Let's reduce first. And then from there, we can multiply it out. So I'll just finish this for us. Root 2 over root 2. That is 6 root 10 over 2. 5 times 2 is 10. Root 2 times root 2 is 2. And I'm going to further reduce, and the final answer is 3 root 10. And that is going to get me to number 2D. So this is a bit of a challenge. before you do anything, how about we make the radicals a little bit smaller, a little bit easier? Why don't we simplify these first, and then we can look to rationalize the denominator. Who's after Dahlia? Claire, are you with us? Can you go up a bit? Yep.
Yeah, I'm here.
Would you mind reducing the root 24 into smallest terms?
It can be 6 and 4.
Perfect. I'm going to write 4 first, just because. And how about the bottom one?
5 and 4.
Good. Again, I'm going to write 4 first. So root 4 is a 2, so 20 times 2 times root 6. Root 4 is a 2, so 3 times 2 times root 5. And we can reduce this further, but now that we have smaller radicals, I think it's easier to work with that. How about it?
You can multiply by root 5.
Good.
So the top becomes 40 root 30.
Mm-hmm.
And then the bottom becomes 6.
6 times?
Oh, 6 times 5.
Which
So
is 30. And then let's reduce that, divided by 10, because they're both, 40 and 30, they're multiples of 10. The final answer is 4 root 30 over 3. There's a lot going on, okay? There is a lot going on, but it's all just a one-step methodical process.
Mr. Kim.
Yes.
I ask a question about the previous one, D of the last. If you could look at how you multiplied these root of 2 and the other root of 2, those two, how did that make 2?
How did that?
Oh wait. Oh wait, now I see it.
Yeah, nice. That's all I need.
Wait, Mr. Kim.
Yes.
How did you go from the 40 and the 30 to the 4 and the 3?
Oh, well, I know that just from reducing 40 and 30, I divided both by 10. I reduced.
Okay, I thought you were dividing them, and I was like, oh, okay, that makes sense.
Yeah. It's reducing. Well, it's fraction things. All right. Any other questions? The rest of these, I'm going to provide answers to online so you can try them on your own time as practice. There's one more type of question I want to throw at you because it involves a little trick. It still involves multiplying by a 1, but you need to know, or you need to see it in action for you to get a better hang of it. It is a bit difficult to entertain the idea on your own. Oh, geez. Okay. What happens when you have a binomial? Impossible? No, not impossible. Again, what if the denominator takes the form of a binomial radical? There is a strategy. We are still multiplying it by 1, but we're going to multiply the conjugate binomial. That's the trick. What do I mean by that? If I'm dealing with x minus y, the conjugate is x plus y, and vice versa. You're going to multiply with the conjugate. I'll say it as one more time as a sentence. If the denominator is a binomial, multiply by 1 using the conjugate. Remember, that is 1, right? That's still a 1. But the denominator here is the conjugate of the denominator here. That's going to be a tip. That's going to be a technique, so to speak. And let's see it in action. This is what happens. By distributive property, the numerator is root 3 multiplied with root 5 plus root 2. And the denominator is root 5 minus root 2, root 5 plus root 2. Color coordinate that. Why would we do this? Okay, some of you who are following so far, some of you might see it already. This might look very familiar to you. Others might have guessed. 3 times 5, that's root 15. 3 times 2, that's root 6. But the denominator, what is root 5 times root 5, everyone?
Root 25.
5.
Or 5. You're both correct. And then root 5 times root 2.
Root 10.
Anyone?
Root 10.
Root 10. Negative 2 times 5, negative root 2 times root 5.
Negative 10.
Root 10. And then negative root 2 times what? So root 2 times root 2 is a 2. What happened?
You got rid of the roots on the bottom.
All the roots disappears. Wow, that's terrible grammar. All the roots disappear, not disappears. Ta-da!
I have a question.
Yes.
Do you have to, when explaining your work, like on a test or assignment for this, do you have to show all of this? Because I would have automatically like assumed that you would just cancel, like they would just kind of equal
Yep.
5 minus 2, because that's
That's
like
fine.
a readable.
That's fine. No, that's where I wouldn't mind people being there. So this right here is an example of a squared minus b squared. This is difference of squares. Doesn't that look familiar? The reason why we're multiplying the conjugate is because we're trying to create a difference of squares. When we do that, the first square root becomes squared, the second square root becomes squared, all the square roots disappear. And I don't have to worry about the middle section because they cancel each other out. So this is a technique. When we have a binomial, multiply with the conjugate, please. Shall we try this? Who's with me? Ashton Falcone? Is that Jose? I think that's Jose. Yeah. Anna, are you with me?
Yeah.
So, following what I just said, I have a root 7 plus a root 3. What would the conjugate be? What's the opposite, or what's the conjugate of that?
Root 7 minus root 3.
So, in the beginning, you might blindly just do it just because I told you, but sooner or later, you will get used to it. What would the numerator be for that, Anna?
Would you do distributive property again?
Yes.
So root 35 and minus root 15.
Good.
and then
Don't worry
7.
about simplifying, just muscle through it. 7 times 7?
Will be root 49, so 7.
Mm-hmm.
And then root 21
Good.
plus root 21,
Mm-hmm.
and then minus 3.
Yes. Good. Right? And just to prove a point, I intentionally wrote everything. So that cancels out. My final answer is root 35 minus root 15 over 7 minus 3. And you have successfully rationalized the denominator. Now that I've thoroughly tired it out your brains, we've actually already reached 3:15. I don't have any more time, but thank you for staying with me. I was a bit ambitious pushing through. Truth be told, part 1 and part 2, if we were in a normal school schedule, I would have done them in separate days. But I've sort of cut out the fat and tried to stick to the main points and squeeze them all into one session. So feel a bit accomplished in being able to hang on, okay, and doing 2 lessons in one day. All of the practice questions here on this sheet, I am going to do an answer key for, and I will put them up online for you. There are more questions that you can practice with on the Waterloo practice. You have 3 things to do. Number 1, finish off your rational expression package. Rational expressions practice. You have your rational expressions problem set that you can maybe get together with some other friends that might have grade 11 math right now. And then number 3, slowly put some work in on radicals, because this is going to also be on a maybe like one of those unlimited trial quizzes sometime in the future. Any questions?
I have a question.
Yes.
Quickly, for the last question we just did,
Mm-hmm.
how did it become 4 at the bottom?
Oh, well, you know how the yellow part cancels out, right? So in my head, I just did this as 7, and I did this as 3.
Okay.
7 minus 3.
Okay.
Yeah. Anyone else? Okay, I'll be here for another couple minutes. For the rest of you, good job. We'll get a break before you try some of these questions. I think it's worthwhile letting your brain digest a bit. You are formally dismissed. Get out of here. Take a break. But don't forget, tomorrow is PA day, and then Monday is family day, which means you get a 4-day weekend. I'd like you to not only enjoy it, but dedicate one of those days at least to keeping up with the material. Don't slack too much. Chunk it down. Take baby steps, but make sure you're not negligent. Okay, maybe do this at the end of today. Maybe do the problem set tomorrow with a friend or whatnot. Don't leave it all last minute. Okay, you'll feel accomplished for that. What were the 3 things? Very quick. Rational expressions problem set, practice radicals. That's where everyone, I think, should be right now. If you're still practicing factoring, I think you need to rush a bit. Any other questions? I don't think so. If not, everyone is dismissed. Go take a break. And don't forget math, okay? Good work. I will see everyone at 8:45 on Tuesday. Oh,
Thank you.
appreciate that.
Thank you.
Thank
Nice
you.
weekend.
Have a good
Thank
weekend.
you.
Bye, bye, bye.
Thank you.
It's like a big slow. Have a good weekend. Enjoy.
Thank you, sir.
Bye.